So in this presentation, I will introduce you like a sort of umbrella of the work that we carry out using Bayesian Network for climate risk assessment against scenario analysis. So I mean, I will introduce you very quick, but in detail, you can contact me for more detail because we don't have much time. So I'm Vuong Pham from CMCC Kafoscari. So as the name said, it's a collaboration between Euro-Mediterranean Center on Climate Change and Kafoscari University of Venice. So we are working on different theme and let's say start. For example, impact assessment at regional scale, economic analysis of risk and disaster risk reduction, as well as like we're developing like participatory approach and decision making. For example, we develop like interdisciplinary approach and tool for multi-criteria risk assessment associated to one or more environmental and climate stressor. We also develop like the tool to let's say analyze the effect of extreme event and meteorological events, as well as the policy instrument to reduce vulnerability and increase the resilience. We also develop and implement GIS-based decision support system. It's called DESICO. So if you want to know more about this, I leave you the link here and you can see it. But specifically, our, let's say, subgroup, we are working on risk assessment of climate change. So you probably heard about climate change. So it is extremely likely that human influence has been dominant cause of observed warming since mid-20th century. So I took this quotation from the fifth assessment of Intergovernmental Panel on Climate Change. And also in the recent report, they repeat again. So it is indisputable that human activities are causing climate change, making extreme climate event, including heat waves, heavy rainfall and drought, more frequent and so. So that is the last IPCC report. So it means that we have to do something. And one of the things we are carrying out is the risk assessment. So it is complex procedure, require collection and modeling of huge amount of data and the integration of different disciplinary spheres. So as you can see the image here on the left-hand side, so risk is a combination of hazards, exposure, and vulnerabilities. And the changes in climate system, as you can see on the left-hand side, or the socio-economic processes, including adaptation and mitigation, are the drivers of those components like hazards, exposure, and vulnerabilities. And in the recent report, they also like provide not only the deep sea framework. So deep sea stands for driver, pressure, state, impact, and responses, but also provide the main interaction and trends between climate change, ecosystem, and human societies. Also provide options to reduce climate risk and establish resilience. For example, human system and transition can adapt and mitigate to climate change in order to reduce the impact of climate change. Ecosystem can also adapt and mitigate to that in order to reduce the impact of future climate change, as well as increase the provision of ecosystem services that they provide. So as you can see, climate risk is very complex system and problem that need to take into account interaction among like natural, anthropogenic processes and hazards. Also take into account the interdependencies among sectors, like for example, energy, food, water, and supply chain, etc. Also, it should take into account global changes, including climate change that I just mentioned you before. And also we have to define multiple compound climate extreme events to build resilient society and system. And more importantly, we need to take into account local stakeholder perspective and their needs. So in this context, we found Bayesian network are useful and it helped to solve our problem and our exercise. And why Bayesian network? because it is probabilistic graphical model. So as you already see before, and it's easy to represent the system component. For example, here you see different nodes represent different variables that we take into account in our model. Also, it facilitates the conceptualization in the system. So Leno already present like how we conceptualize and translate in the network. And here we do the same. So for example, hazard, exposure, and vulnerability is 3 different components, and we were able to translate from the conceptual framework into the real network. Another point is that it allows the consideration of multiple stressor and endpoint assessment endpoint. For example, here you can see we consider like 3 different assessment endpoint, namely agricultural damages, residential damages, and industrial damages. So I will come back to this publication later. And also one of the strength point of Bayesian network is to the integration of different knowledge domain experts and also integration of different data sources from different sphere and complex system. So practically the implementation of Bayesian network that we carry out in 5 different steps. Previously, you see Leno already present in different way, but I think more or less the same thing. So we start with the conceptual model to model parameterization, calibration, scenario analysis, and the sensitivity analysis. So from beginning, we start with the definition of structure of the network, identify the main variables and the relationship among them using the nodes and arrow diagrams. And then we're applying different learning processes to extract the network structure, but it needs to be fine-tuning by expert because it's data driven. So expert need to let's say validate the model again. And after the conceptual model was built, the second step is parameterization by defining the state for each variables. So the state depends on the natural characteristic of the variables. For example, if it is land use, so it should be land use classes, or if it's like discrete data or continuous data. And also the number of classes depend on the need of the model. And then we calibrate and validate the model by evaluating the performance, the prediction accuracy of the model. So it can be done by different approach in which data-based validation and qualitative evaluation can be done. Then after we verify that the model is good, the validation, calibration is good, we move to the scenario analysis by inferring the behavior of variables. So we change the setting of specific state or a set of nodes with evidence, and then propagating information among the network and have the posteriori probabilities. And the last step, to identify the relative impact of each parameter in the output, we carry out the sensitivity analysis by fixing own variable and changing only one. So it is a stepwise modification of individual input parameters. And then we will identify which variable have like strongest impact on the final output. So on this step was implemented in R using package BNLearn and its dependencies. So this work package were written by Marco Sputari, and also he helped me a lot on the model by giving me some advice. Unfortunately, I did not have chance to use BayesiaLab. I mean, I was one subscriber, but when I was PhD student, but I was not able to find the funding source. And then we published our work in different journals. So the first one in 2020, we published our work regarding the multi-scenario analysis of the Adriatic Sea to support marine spatial planning in science of the total environment. And then we published the second paper in 2021 regarding the Bayesian network for ecosystem services. assessment to support water management at the river basin scale. So it was one of the paper in the context of my PhD thesis. And the last one we recently published in climate risk management. So we built a Bayesian network approach for multi-sectoral flood damage assessment and scenario analysis. So in the next slide, I will present you one by one, but this will be an overview, but not in detail. So the first application, we developed a Bayesian network, GIS Bayesian network to support the marine spatial planning. So as you can see, the domain is marine and coastal ecosystem, where we have like the interface between sea and land, and you have the pressure from not only from the marine, from the sea, but also from the land. So here the risk come from different sources. So our exercise to quantify the multi-risk from different sources and to carry out the scenario analysis. So as you can see here from the left-hand side, so this is the workflow that we carried out. We collected a huge amount of spatial data in different domains, and then we build a conceptual framework and translate them in the Bayesian network model. And we carried out 4 different scenarios. So the first one regarding the, let's say, the effectiveness of the establishment of new marine protected areas. So we would like to know what is the effective of marine protected area in reduction of risk in the marine domain. The second scenario is we call a boiling sea. So we would like to understand the influence of rising temperature and anthropogenic, chronic, and acute chemical hazard and cumulative impacts. The third scenario is we would like to understand what is the impact of increasing nutrient input to the Adriatic Sea. And the last one, we would like to understand what is the requirement management measure and adaptation strategy need to implement in order to reduce the risk in the Adriatic Sea. So from the 4 scenario analysis and the exercise, we identify that the integrated approach to marine spatial planning is the key answer to substantially reduce the cumulative impact on the Adriatic Sea. The combination of more sustainable management option of marine spaces and resources with climate adaptation and strategy would allow to reduce human pressure on the marine domain, as well as like increase the resilience of natural ecosystem and their services they provided. And then the second application, we move from the sea to the land. So we focus on freshwater ecosystem. So as you can see here, that one example of a lake or freshwater ecosystem. So they're surrounding and different stakeholders, different users, and there's conflict among users. So the question is how to balance the conflict, to reduce the conflict among users and balance their needs. For that reason, we also collect a huge amount of data, spatial data in different fields, for example, meteorological data regarding the precipitation. We also collect data regarding dams, land use, and soil characteristics. And also we obtain the value of ecosystem services. So this is independent work. I mean, the ecosystem services quantification will carry out in another publication that I also put the link in the end. And we build the Bayesian network in order to build sort of ecosystem services space, meaning that like all the combination of model input are translated into ecosystem services, where the value of selected services, here we concentrate on 3 main services, namely water yield, nutrient nitrogen retention, and phosphorus retention. So all these services are plotted in space of ecosystem to represent the gain and loss of additions. So it has to identify different, let's say, zone areas. So the win-lose mean we maximize one service while we reduce the value of other services. Win-win area mean we balancing all the services. Also, this framework allowed the evaluation of what-if scenario representing different management strategies and options, and also regarding the precipitation, it related to the different climate scenarios. It also allowed to incorporate expert knowledge with wiring of multiple spatial and temporal data, for example, socio-economic and environmental domains. It also helped to identify what are the best practices, management practices for sustainable use and improving water quality, and also the services that they provided. And the last application that we recently developed is Bayesian Network for multi-sectoral flood damages assessment. So we applied to the Secchia River Basin in Italy. So in January 2014, the Secchia River Basin were hit by long-last strategic from rainfall event, which lead to significant spread to the dike system and local rivers. So about 50 square kilometers were flooded and with an average depth of 1 meters. It lead to the damage to different sectors, for example, agriculture, residential, and industry. Also, during this event, we have good monitoring data, and also in the end, we have the report from local communities about the damages that they had. So that's why we built an integrated model for risk assessment and flood damage prediction to capture the damage of multi-sectors with relation to the event 2014 in Secchia River Basin. And also we carry out scenario analysis. So the damage we consider in this framework regarding the residential damages, industrial and agricultural damages. So those are the damages that we have data. I mean, in the end of the event, they carry out some sort of investigation and also report. So each community, they carry out by their own and they collect huge amount of data. We also carry out a what-if scenario regarding the damages with different return period of flood events. So we would like to understand what if in the future it happened in the same event or the event with higher return period. So this work were published in climate risk management journal recently. So what is the cross-cutting message from those applications? So we understand that Bayesian network models are useful in this kind of exercise because it allowed the integration of different domains, for example, like marine domain ecosystem services damages with different perspectives from environmental, social, and economic science. Also, it allows the consideration of uncertainty about climate change. For example, in our case, we try to understand flood map, the damages with different flood map with different return period. Also, we take into account the precipitation condition in the future. Also, it allowed to consider like the uncertainty in policy and management scenarios. For example, the establishment of marine protected areas. And then it allows the combination of quantitative and qualitative data and approaches. For example, in this case, it can be monitoring data. It can be simulated data for the flood event, and also expert judgment in a single model. It also allowed to the consideration of wide range of options in order to develop integrated management scheme to balance the use and exploitation, conservation of marine environments and other domains. It also considers the dynamic behavior of pressure, hazard, and vulnerabilities when you are talking about risk assessment in temporal and spatial domain, because all of our data in the spatial domain. Also, stakeholder involvement is one very important aspect to tailor the approach, and we understand their needs, the perspective, in order to fine-tuning the score and also the connection among variables and among the nodes. The last point is the communication and the translation of knowledge between science and practitioner interface, because those tools are useful to have a decision maker to design the management and policies. Nevertheless, there's still some gaps for the next, let's say, the future work. For example, the integration of spatial and temporal resolution in the output of the model. Because all of the publications that I show you until now, so we are, have like the input variable is the spatial temporal data, but the output is only the probabilities corresponding to the static data that we have. So we would like to build the spatial temporal Bayesian network model. Sorry, there's a mistake here, model, yeah. And then another aspect is the consideration of the spatial temporal interactions of the input variable itself, because we didn't consider, for example, the effect of previous step or the next step, the next time step into the time step t, but we have only the static data at a certain time. And another point is the interaction between one, let's say, pixel or one community to the next one, in case we compute, we have the spatial data. So we didn't take into account the influence of neighbor cell to a specific pixel. And the last one is to bridge the gap between researcher, practitioner, and decision makers, because like stakeholder involvement is what we try to doing, but it's not really effective yet, because we need to take into account their need and also to design the future for their need. Also, we need to develop a decision support tool that is, let's say, have user-friendly graphic interface, because in our case, we don't have, let's say, a software, a web, or anything, but only the final result in report. And also, we need to get the feedback from them. So that's why I'm here. I would like to share my knowledge and also would like to learn from you. So this is a question that I put from beginning, but now, I mean, after the presentation of Leno, I think Bayesian can help to solve some of the above mentioned aspects, right? Because like the interaction between stakeholders and practitioner and scientists can be done by the stakeholder involvement that you showed before, the interactive processes, and many others aspects you already show. So it's fit to our need. So we're still working on Bayesian network and their applications. So we already submit 2 papers, and we are trying to constructing another paper. So we mainly focus on coastal erosion risk and the assessment of water quality change and coastal erosion. So we submit 1 paper to environmental science policies, and the other to climate risk management, and they are under review. So please stay tuned to update our next publications. I leave you here some link to our publication and some useful references. And if you want to know more about our work, and if you have any suggestion, question, feel free to drop me an email. So I leave you the link here and also my email address. Thank you very much.